Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In this problem, we have an 18-year-old who is running a 10-kilometer track. I'm going to jot this information down as we kind of cover it. A 10-kilometer track. And for that track, he is running at 4.39 meters per second. Now, the same track is run by a 50-year-old, but he only runs 4.27 meters per second. Now, those two velocities are very close together. They're almost the same thing, honestly, but over a distance of 10 kilometers, the time it takes to run both of those is going to be dramatically different. Now, before I plug my distance in here, I want to take a second to note that this distance is given in kilometers, but our base unit for distance is meters, which is why our speeds are in meters per second. So before we plug it in, I'm going to convert my kilometers into meters. And since there are 1,000 meters in a kilometer, a 10-kilometer track is a 10,000 meter track. So both of these distances here are going to be 10,000 meters. Take a second, jot those in. Now, this problem is looking for the difference in the time it takes the 18-year-old to run the track and the 50-year-old to run the track. So that's going to be done with our speed equals distance over time equation. Now, usually in problems, it's worth taking a second to rearrange your equation to find what you're solving for, particularly for problems like this, where we're actually going to need to do the same calculation 2 times, once for the 18-year-old and once for the 50-year-old. So if I wanted to solve the speed equals distance over time equation for time, I would multiply both sides by time because I'm trying to move it over. So we'd multiply both sides by that time value. And then we would divide both sides by speed. And that ends up with our new equation here, that time is equal to distance divided by speed. So what that means is the rest of this problem is just plugging in my numbers that I solved for initially and finding what the difference in the times is. So for the 18-year-old, we have 10,000 meters divided by the velocity of 4.39. And for the 50-year-old, I have 10,000 divided by the velocity of 4.27. Now my times I get are a little bit different here. For the 18-year-old, we get 2,277.9 seconds. And for the 50-year-old, we end up with 2,341.9 seconds. Now, when I grab a calculator and find the difference between those two numbers, I find that the 18-year-old finishes that race 64 seconds earlier than the 50-year-old.